Once we have our crash, we can investigate the root cause with the debugger. So first we have to clean the Xpdf directory and the install directory and restore it with the debug symbols. So we delete this one, we do make clean, and then we run configure using the debug symbols. -G for debugging and -O0 to disable any kind of optimization. Now we can make it and make install. With the binaries compiled with the debug symbols, now you can use your favorite debugger to investigate the crash. In that case, I will use Visual Studio Code with GDB. So like before, I will go on Run, Add Configuration. I click again Add Configuration with for C++ with GDB. Now I will change the program and the args. In program, I will put the PDF to text binary compiled with debug symbols. And in args, I will put as a first argument the PDF file generated by AFL, our crash output. And as a second parameter, I will put just an output directory, the path of my output. So now I can run with the debugger the PDF to text. And as you can see, we easily can find in which line the program crashes and the reason, segmentation fault. Now, if you want to know more about the root causes, you can go on the debugger tab and look to the call stack. Going through the call stack, we can see that here the get object is called and the parser get object function is the one incriminated. If you want, you can try to fix this version of Xpdf and patch it in a way that you can generate your patched version of Xpdf and try to make it crash again with this input, or trying to find other vulnerabilities with AFL.